So as we start to close out, we have chapter 16 working with exponential expressions, equations, and formulas. So working more with what's called an exponent. So let's look at question 3. The number of grams of a certain radioactive substance present at time t is given by the formula A equals 100 times e to the negative 0.008 t. So it's like negative 8 thousandths t, where t is the number of years. Find the number of grams that are present at t equals 0, and then at time t equals 600. So times 0 kind of means starting now, and then t is like 600 years later. So the number of grams of a certain radioactive substance. So if you follow radioactivity, um, sometimes radioactive stuff is very dangerous to the human being. A lot of times they treat cancers with radioactive treatments to kill the cancer, but they're also very deadly to the human body if you treat too much in the treatment there. So it's kind of a pro and con of radioactivity. So A represents the amount of radioactive substance in grams. So we have this, but this formula has 100 times e to the negative 8 thousandths t. So all they're wanting us to do is determine the number of grams present at t equals 0. So what they want us to do is, using this formula, A equals 100 times e to the negative 0.008 t. That's our formula. But what they want to do is change the time to 0. So A equals 100 times e to the negative 0.008 times 0. So again, when you multiply by a 0, the whole exponent will turn into 0. So A equals 100 times e to the 0. Now, remember, anything to the 0 power is actually 1. So e to the 0 actually represents 1. So 100 times 1 would just be 100 grams. So starting out with, we have 100 grams of radioactive substance present. Remember, a gram is like a paper clip. So it's like 100 paper clips. So that's quite a bit of substance there at the beginning. Now, again, we can use the calculator and type in to our formula. We could type in 100, and then E is right above this ln button. So there's this e to the x. Say it's second, hit the ln button, there's the c to the x. And notice it's now prompting for the exponent. I could then type in negative 0.000, no, just two zeros. So negative 0.008, and then I can multiply that by 0. So if I just replace t with 0, the calculator actually could do that calculation, and that would be 100. Now, e itself is on the calculator, so e is an actual number. So e is approximately, notice that right above the division symbol, there is this e symbol. So if I hit the second button and hit the division symbol, e is going to be, so notice how it's actually a number, it's not a variable. So e is what we call an irrational number. So a lot of times it's rounded out to like 5 decimal places, so 2.71828. That's usually what's used in a lot of books for e. But our calculator actually has e on it, so we don't even have to use an estimation. Now, our next question is, time is going to be 600 years has gone by. So keep that at 600 years. That's a lot of time. So more than 6 times longer than I'm going to be around. So 100 times e times, and raised to the, I should say, negative 0.008. This time we'll multiply by 600. This will tell me how much radioactivity radioactive substances left after 600 years. So if I put that into the calculator, 100, and then E, and then raise this to the negative 0.008 times then 600 years. This formula will tell us how much radioactive substance is available after 600 years. So notice that there is still some left. So they say round to the nearest hundredth as necessary. So that would be like 0.82 grams. So not quite a gram of radioactive substance left. But notice how there is still some of it left. So that's pretty impressive that after 600 years, there's only 100 grams present to begin with, but there's still almost a gram left after 600 years.